All right, ladies and gentlemen. So today, welcome to class. Today we are going to be learning about Avogadro's number. Last class, we learned a little bit about molar masses, and we've talked about Avogadro's number before, but now we're going to practice converting Avogadro's number. So just as a quick review, ladies and gentlemen, let's take a look at what Avogadro's number, or a mole, actually is. So what is a mole, ladies and gentlemen? Well, it's a number. And that's all a mole is. It's just a number. Like the word a few means three. So if you ask somebody for a few dollars, they're going to give you $3, no more, no less. You ask for a dozen, you're going to get 12 of something. You ask for a gross of pencils, you're going to get 144, which is a dozen, right? If you ask for a mole of something, you're going to get 6.02 times 10 to the 23rd, which you watched a video on, which is something like 602 hexillion, some ginormous number that we can't even visualize. I think I just read that if you had a mole of dollars, you could spend $1 billion a day. No, $1 billion a second. $1 billion every second, and it would still take you 19 million years to spend all your money. It's a huge amount of money, some ridiculous number. You can look that up. It was just online. So, but how much is a mole? Well, ladies and gentlemen, if you had a mole of mercury oxide, we take about this much. If you had a mole of sugar, we work this number out. It's 180.18 grams equals 1 mole for sucrose. Sulfur, to have a mole of sulfur, you can see that. So this amount right here is about 32 grams for 1 mole of sulfur. All right. Sodium chloride, it's going to be chlorine, which is 35.45, plus sodium, 22.99, and it's going to be 35 and 22 is going to be 58.44. Okay, so it's going to be 58.44 grams for every mole. So if you weigh out 58.44 grams, you'll get 1 mole of salt, or sodium chloride. Copper, which is right here, weighs 63.55. So that's what 1 mole of copper is. So if you had 1 mole, that many molecules, you would end up with 63 grams of copper, or you'd end up with 58 grams of sodium chloride. But if you had a mole of basketballs, and this is just to show you how small an atom is, ladies and gentlemen, a mole of basketballs would be about equivalent to the size of the Earth. So if you took, let's just say, this amount of water right here, this amount of water, which for size reference, this is 1 mole of water. This is 6.02 times 10 to the 23rd molecules of water. And if each one of those molecules, when I snap my fingers, which I'm not going to do it because I'd hate for it to come true, but if I snap my fingers and each one of those water molecules turned into a basketball, we would have a pile of basketballs the size of the Earth. The Earth would be wiped out. So that's it. That's what we had talked about with moles. So what do we take from that, ladies and gentlemen? Atoms are really, really, really small. Because if a mole of basketballs is the size of the Earth and a mole of water fits in this cup, then that means that atoms are a lot smaller than a giant basketball. So small, we can't see them, ladies and gentlemen. I don't know if we've seen atoms before. So what we're going to do, I know we have, but it's digital. We can't actually see an atom. Digitally, we can make a digital representation of what an atom looks like to us, but we cannot physically see it. All right, so ladies and gentlemen, we are going to review from last class what we did on molar mass conversions. So let's just review. What is molar mass? Molar mass, ladies and gentlemen, is the mass, I guess I could put it here, is the mass of 1 mole. So the molar mass is the mass of 1 mole. It's how much 1 mole weighs, or its mass. For example, we talked earlier, this sodium chloride weighed, we said 58. That would be its molar mass. That's the mass of 1 mole of sodium chloride, okay? So what we want to do, we want to just review how we solve for conversions with molar mass. So whenever we work out a problem, the first thing we want to do is read it. So it says you have 25 grams of water. Okay, we're given 25 grams of water. We want to know how many moles of water. Remember, step one, always write what you're looking for. Right? Write what you're looking for. Step two, always write what you're given. If you can do that, chemistry becomes so easy. All right? Because you end up just having to solve these math problems by cancellation. All right? There's still other stuff to learn in chemistry, but the mathematical portion becomes easier. So we would write in here moles of water. Now, I'm usually never going to write out the word water. Okay? When I say the word water, I actually visualize the word H2O. So we're looking for moles of water. You want to put an S on that? Fantastic. Oopsies. Moles of water. All right. What are we starting with? We're starting with 25.00 grams of water. Now, I'm always going to abbreviate the word grams. All right. So we're looking at this and we say, okay, well, we're good. We're trying to convert grams into moles. Do we know a conversion factor, right? Do we know a conversion factor, ladies and gentlemen, that converts grams into moles? So we're trying to go from grams into moles. Do we know anything? Sure. We know the molar mass. Whoopsies. The molar mass. What are the units for molar mass? The units are grams per mole, or mole per gram, because when we're using conversion factors, we can reverse those ratios. So what is the molar mass, ladies and gentlemen, of water? Well, let's work out the molar mass of water very quickly. In order to find this conversion factor, we need to look where? That's right, we need to look to the periodic table. All right, we got to look to the periodic table. So the periodic table is going to give us our conversion factor. So we have oxygen and we have hydrogen. So we have two hydrogens in H2O, and those two hydrogens are going to be, each hydrogen is worth 1.01. So just because I'm a mathematical genius, I can do 1.01 and 1.01 in my head. One oxygen, because H2O has one oxygen, it's going to weigh 16. And again, I don't need a calculator because I'm a mathematical genius and I can add these numbers without a calculator. So what do we have though? Well, let's look. We have to put down the most important part, which is going to be its unit, which is going to be 18.02 grams per mole. That is the mass of 1 mole. That is the molar mass. Those are the units we use. So whenever we have to convert grams into moles, we use the periodic table. All right, so let's work it out. We just said that the molar mass equals 18.02. Now the question is, are we going to put the 18.02 on the top or the bottom? So I just quickly put this up here. So this is ratio A, 18.02 grams of water for every 1 mole of water. This is ratio B, 1 mole of water for every 18.02 grams of water. Which one of those ratios will we use, ladies and gentlemen? That's right. We're going to use ratio B. We're going to put 18.02 grams of water on the bottom. Why are we going to do that? Because we want to cancel out the grams of water. And on the top, we'll put 1 mole of water. Let me just copy that. All right, 1 mole of water. And the purpose is so that these cancel out. The reason is so that these words, grams and water, cancels, leaving us only mole of water. So our final answer, 25 times 18, we'll take out our calculator. And after we work that out, we're gonna take 25 times 1, and then we're gonna go divided by 18.02. So 25 times 1 divided by 18.02 equals, ladies and gentlemen, 1.387. 1.387. Like I said, when we're working out our numbers, we're always going to have at least 3 numbers after the decimal place, all right? And always keep these numbers where it says 24.30 or 22.99. Don't round that to 23. All right, so with that said, let's start our next section on Avogadro's number. So ladies and gentlemen, let's just take a look at this problem. We're going to be using Avogadro's number, which has 2 ratios. One is going to be there's 6.02 times 10 to the 23rd particles per mole. The other one is 1 mole has so many particles. What do I mean by particles? Particles could be anything you want. It could be basketballs, it could be ping pong balls, but what we're going to be doing the most is we're going to be doing atoms and molecules. So whenever we're asking for individual numbers of atoms or molecules, we'll be using one of these 2 conversion factors. And we'll be using Avogadro's number, which is like saying a dozen, but we're asking for a mole. So let's work this problem out. I will work out 2 problems. If you get confused, obviously, come and talk to me. I'll be sitting right here. But if you work out these 2 problems like I teach you, then you're golden. You don't have anything to worry about. Okay, really quick review. Step number 1. What's the first thing that we have to do when solving a problem? That's right. We first write what we're looking for. What are we solving for, right? What we're looking for on the line. What's the second thing that I want you to do? That's right. You're going to write what you're given to work with. Okay, so here we go right here. Let's read the question and solve it. It says you have 1.45 times 10 to the 25th atoms. So you have this many atoms of nitrogen. And it says how many moles of nitrogen? So here's my question. What are we looking for in this question? What are we trying to solve for? That's right, we're solving for moles of nitrogen. Now remember, to make the little subscript 2, I'm going to push the control and the comma, and that's going to give me the subscript. If I want to make it a superscript, then I'm going to push the command or control and the period using Google. All right, what am I given? I'm given 1.45 times 10, and now I'm going to use the control period button to the 23rd. I'll push it again to bring it back down, and I'll write atom, so I don't have to waste my time with the S, of N2. All right, so that is what we're given. Now here's the question. What word or words do I need to cancel out in order to get to moles of nitrogen? What words do I need to copy out in order to get to moles of nitrogen? That's right, I need to copy out the word atom. So I need to get the word atom right down here. What word do I want to have on the top? Yep, I want to have the word moles right on the top, moles of nitrogen. So here's my question. We have 2 conversion factors here. I'll put these in green. We have A and we have B. Which one of those conversion factors, ladies and gentlemen, are you going to want to use in this problem? That's right. In this one, you're going to want to use B. Now, even though it says particles, we're talking about atoms or molecules. And so we're going to put that down. So on this one, I'm just going to copy this. It's going to go a little faster, right? 6.02 times 10 to the 23rd. But I want to then write down atoms of N2. Now I noticed on a couple of your homework, you guys did not write down, some of you did not write down all the words. And I took points off. I gave you like a 2 out of 4 points, even though all the answers were correct, because I wasn't impressed by the answers. So this is all set up perfectly. Now what we want to do, we want to calculate this thing out. So in order to solve this, we need a calculator. So what you're going to do is you're going to go to the home screen of my page, and you'll see a calculator button right in the middle of my screen. You're going to click on that calculator button, and it's going to take you to this little Desmos scientific calculator. Me, I'm going to pull it out of there so that I can put it on my screen. And then we're going to pull it right over here so that we can use our Desmos calculator. And then here we are back on our home page. So, Mr. P, show us how to use this calculator. Will do, kids. So what we want to do, we want to take the number 1.45 times 10 to the 23rd. My suggestion is always put parentheses down. So you're going to go 1.45, okay? And then you're going to have to push times. There's a little dot there. That's how they do times nowadays. 10. And then we want to raise it to the 23rd power. So we're going to push that A to the B button. You're going to go to the 23rd power. And then, well, don't click it again. And then you're going to click out and you're going to put the parentheses. Okay? You don't want that there. There we go. To the parentheses. And then we want to multiply times 1. We don't really need to multiply by 1, but you multiply the numbers on the top. Then you're going to divide. We'll push the divided button, right? We're going to put parentheses again, just because it's going to be a little nicer. We're going to put in 6.02, and then times 10 to the power of 23. And then we're going to close our parentheses. Click out, close our parentheses. And at this juncture, it's exactly what we want. And then, boom, we're going to push equals. All right, so we push the enter button. Oh, it gives it to us right here. There's our answer, 0.2408. So my answer, ladies and gentlemen, I'll write this out, okay, is 0.202 is 0.2408 637874. Don't ever write that number. You only want to keep the first three numbers after the decimal place. Okay, so you want to keep this many numbers right here. But you can see that the number next to the 8, or next to the 0, is an 8. So the 8 is going to round that number up. So our answer is actually going to be 0.241 moles of nitrogen. And that's how we would solve that using the calculator. I highly suggest that if you aren't sure how to use this Desmos calculator, you work it out. If you have your own calculator, just make sure you have this answer. All right, so let's move on. Let's do the next problem. All right. All right, ladies and gentlemen, so now our next problem that we have, all right, this question asks us, if you have 12.5 moles of chlorine gas, how many atoms of chlorine do you have? So you're given 12.5 moles of chlorine gas. The question is, how many atoms of chlorine do you have? So let's work it out. First thing we do is, that's right, we write down what we're looking for, which is atoms of chlorine, okay? What is the second thing we're going to do, ladies and gentlemen? That's right, we're going to write down what we're given, or write down what we're asked to convert, which is 12.5 moles of chlorine gas. Now, we're asked to convert from moles to atoms. Does anyone know a conversion factor that converts from moles to atoms? Am I going to go and use the periodic table? Will I come over and get my conversion factor from the periodic table? No, I will not. That's right. Where am I going to get my conversion factor? It's going to be Avogadro's numbers. But instead of atoms on this one, instead of particles, our particles are now atoms. So all these would be atoms in theory, not particles, right? If I was working with molecules, I would have changed this word to molecules. So here's my question for you here. This is going to start going faster. All right, hopefully you guys are like, oh my God, Pepe, we totally got this. There's A and there's B. Question, which one of these conversion factors are you going to use? Whoopsie daisy, yep, I got it. Which one of these conversion factors are you going to use in this conversion factor right here, A or B? That's right, we're going to use conversion factor A because we want to cancel out the moles of chlorine atoms in this case. It'll be 1 mole, okay, of chlorine atoms, all right? I don't write the word atoms because it becomes redundant. It's like saying, how many pencils are in a dozen pencils? And you'd be like, or how many pencils are there in a dozen? It's the same as saying, how many pencils are there in a dozen pencils? It becomes redundant after a while, but so 1 mole of chlorine atoms would be how many chlorine atoms? It'd be 6.02 times 10 to the 23rd, right? And now we're pretty much done because we can see that moles of chlorine will cancel with moles of chlorine. Now we just have to go get our answer. So let's see if we can work this out. Remember, we multiply all the numbers on the top and we then divide by the numbers on the bottom. So let's start off. We're going to be right here, 12.5, 12.5. And what are we going to do? We're going to multiply. Now, in my life, I like parentheses better because it keeps things together. So 12.5, and then we're going to go times. We'll put another set of parentheses here, and then we're going to put in the 6.02. Hopefully you guys are getting good at memorizing this number. 6.02 times 10 to the 23rd. And remember, I'm going to push this A to the B button right here. If you can't see what button I'm touching, it's this button right here. So I'm going to reach down in there. I'm going to touch that button right there. And whoops, I want that on the inside of my parentheses though. And I'm going to go to the 23rd, right? And then I'm going to divide by 1. You want to divide by 1? Fantastic. Divide by 1. Let's see what happens. All right. So what's our answer? Well, 12 moles times this many atoms is going to be 7.525. Now, if we take a look, remember what I said, we're always going to want to have at least 3 numbers after the decimal place if possible. We have those 3 numbers, which means we are going to keep all of these digits. All right, so let's keep all of these digits. So the answer is going to be 7.525 times 10 to the what, 24th? Is that what it is? Let me see. No, there it is. Times 10 to the 24th. All right, and I'll back that up so the spacing is on. So that would be the answer. That's how many atoms are in 12.5 moles of chlorine atoms, okay? That's our answer. I really hope everything is understood. Please come back to me if you have any questions where you're like, man, I just can't figure out how to use it. Again, this is just going to be Avogadro's number handout. Now, next class, we're going to start putting things together. So if I'm looking to go from moles to atoms, we'll use Avogadro's number. If I'm looking to go from moles to grams or grams to moles, I'm going to use the molar mass. So it depends on the words, all right? And we will take like we'll do some practice on which conversion factor we'll use in which situation. Again, I'm sitting here working. So if you have any questions, please let me know and I'll work with you. Again, if you're stuck on one little part and you're just like, oh man, I'm so confused, I just can't make the connection, ask me. And I've been working with kids where they go, oh man, I'm stuck, I can't figure it out. And I go, well, let's look at it like this. And then students are going, oh my gosh, yes, I see it. And then they can work out all these handouts. They can work out the problem sets. So take the time to just fix that one part that you're struggling on. All right, you guys and girls, good luck on your handout, and I will see you later.